forget I have to start all of these things. Let's do. Hello. Okay. Weather is such a broad topic. So I had this 21 slide presentation plan. We're going to dive into it, but I want to try something else first. So when you guys get into the airplane, does anyone here have ForeFlight already? You have ForeFlight. You're not quite flying just yet, right?
My dad has ForeFlight.
Perfect. Play with it. Sandra, do you have ForeFlight?
No.
Okay, not yet. Do you have a Android or an Apple? Okay, so it'll be a different app. Either Garmin Pilot, I believe, is Android friendly. There's another app called iFly. Dale does iFly, so maybe ask Dale about it. When you get in the plane, you're going to do all your checklists after you pre-flight and whatnot. Sitting in the plane, you're going to start up the plane, and then you're going to tune in to the weather frequency. For McClellan, it's 125975. How I could tell just by looking at the chart. Here's McClellan. AWOS, Automated Weather Observation System. It's either observation or observing system. Same idea. Automated Weather Observing System. 125975. So you would tune that into COM 1 or COM 2. The planes that girls love to fly, we have 2 COM boxes. We have COM 1, COM 2. Hello, welcome. I'm kind of talking about like when you get into the plane and you tune into the weather frequency and listen to the weather initially. Stephanie, you probably already know how to do that. Okay, cool. So we're going to dive into that a little bit. So 125975 for McClellan. For other airports, it'll be a different frequency. So for example, come down here to Sacramento May 3rd. They have an ATIS. Honestly, I can't remember what that stands for, but it's a step up from an AWOS. And it's actually a real person talking. And their frequency is 118.325. So at whatever airport you're at, you would tune into the weather frequency. It'll be on the chart point blank. But if you're on ForeFlight or pretty much any kind of aviation app, if you just click on the airport, or if you're on a phone or an iPad, you'll tap on it. If you go to, there's weather, but if you just go to info, the tab to the left, frequency's right there as well, 125975. Some of them happen to have a phone number to where you could actually call it on your phone and you'll get the same voice on there talking to you, but it'll be on your phone, which is super fancy. So I have my phone, so we're going to do that so you guys can kind of hear it.
I was going to say, I was doing that and practicing on the
ForeFlight
app.
Perfect.
Just listening and just kind of entering the info on that app.
So I want you guys to write down whatever you can, whatever you hear. It might not make sense, but just try to write it down. And I'll write it down too on the scratch pad. So you've tuned in the frequency, 125975, or whatever airport you're at. Nut Tree is probably different. We'll call the phone number. Of course, it's busy. I'll try again. Oh, didn't mean to do that. Doesn't usually ring for this long, so we'll see what happens. One more time, and if not, we'll just try a different airport. Okay, let's go to a different airport, because that doesn't want to work. So let's go over another airport you'll probably fly. If you're flying out of McClellan, you'll probably go to Lincoln at some point. So we'll try Lincoln. So there's Lincoln. I'll go to their weather on my ForeFlight on my phone. Ignore that for now. Now start. Now listen.
Lincoln Regional Airport. Automated weather observation 2311 Zulu weather wind 260 at 6 visibility 10 clear below 12,000 temperature 33 Celsius dew point 4 altimeter 2980 remarks density altitude 2,300.
Good. Want to do one more time? Okay.
Lincoln Regional Airport. Automated weather observation 2311 Zulu weather wind 260 at 7 visibility 10 clear below 12,000 temperature 33 Celsius dew point 4 altimeter 2980 remarks density altitude 2,300.
Okay. So now we're using Lincoln as an example. Is anyone familiar with Zulu time? Okay. Basically, it's like, so if you know military time, you can kind of figure out Zulu time, but it is slightly different. So, well, it is different. So Zulu time is just basically the baseline that all pilots use so that we're all on the same page in terms of what time it is. Because, we have different time zones. So we all use Zulu time, which is basically just the time in Greenwich, England. So whatever the time in Greenwich, England is, that's what Zulu time is. So we're either 8 hours, they're either 8 hours ahead of us or 7 hours, depending on if we're in daylight savings, which we are. So now it's 7 hours ahead of us. So it said 2300 Zulu, so 2311 Zulu. Is that what everybody heard? Yeah. Okay. So you would take 23 and subtract 7, which, if I can do math properly, 23 minus 3 is 20, and then minus 4 is 16. So 4 o'clock, which it's 4:11. So it's 4:11. Does that make sense? I subtracted 7 from 23. I got 16:11. That's military time. Convert that to local time. So that's Zulu time. Again, it's just the baseline for everybody. 260 at 7. What is that? Do we know? Who knows?
The wind speed, right?
Correct. Well, 260 is the direction. So 260 is the direction that the wind is coming from. The wind's coming from 260, which is basically the west, because 270 is the west. So close enough. 260. At 7, that's the wind velocity, so that's the speed. And it's all in knots, so it's not miles per hour, it's in knots. We use knots for everything, and we use nautical miles, like sailors. So you could roughly, I don't know, if you were to roughly guess, it's around 9 miles per hour for reference. So it's a little windy. Visibility, 10 miles. 10 miles visibility. That's in statute miles. Visibility is in statute miles. Sky condition was clear below 12,000. So the skies are clear below 12,000 feet, aka there's no clouds. Temperature is all in Celsius. It's 33 degrees Celsius. The dew point is 4 degrees Celsius. So what the dew point is the dew point is the temperature at which the air becomes saturated. Basically, it means the air can't hold moisture anymore at 4. If the temperature were at 4 degrees and the dew point's at 4 degrees, what ends up happening is you get visible moisture. So you get like fog. So if you go to Monterey, for example, probably not right now because it's warm, but like in the morning, if you look at Monterey or any airport along the coast, usually the temperature dew point will be almost the same. So the closer these numbers get to each other, the more likely you're going to get fog or just visible moisture, which usually means fog. So right now they're pretty far apart, so that means the air is pretty dry. The air would either have to cool down to 4 degrees Celsius, which is not likely, at least in this time of year, or the dew point would have to rise to 33 degrees Celsius in order for those two to meet, which again is also not likely. Unless maybe you're in Florida it's high humidity in Florida, California. It's not too humid here. So really the main way that those two meet is when it's cooler. So like in the fall, you'll start to see that temperature dew point spread get closer. And then again, you can expect there to be fog. Something also to think about in terms of fog and visible moisture is kind of the environment that the airport's in. You wouldn't think necessarily that Lincoln is a place that gets super foggy, but it actually does. It gets super foggy in the fall into the early winter because it's surrounded by farmland. There's a lot of grass nearby. Grass holds moisture. So it can get super foggy at Lincoln. It doesn't normally get foggy at McClellan because McClellan is just surrounded by asphalt and concrete. So asphalt, concrete, they hold on to heat. So, not that it can't get foggy, but if you're talking about Lincoln versus McClellan, Lincoln's more likely to get foggy. Altimeter settings, 29 or 80. So your altimeter, that tells you what altitude you're at in MSL. MSL is mean sea level. Oh, hello. How's it going? It's okay. There's traffic right now, which is weird. So we're diving into weather when you're listening to it on the frequency in the airplane. Have you flown yet?
Like what?
Like one time?
Yeah, just one time.
Okay, perfect. So you would get into the plane and you would dial a certain frequency for the weather. I'm using an app called ForeFlight. So do you have an iPhone? No, you don't. That's right. No. There's other people with Samsung. That's fine. So I would suggest, if you're a Samsung person, you might want to invest in an iPad mini. Okay. Specifically because ForeFlight's just the best app for pilots, for aviation. There's other apps too that are more Android friendly for your phone. I don't think any of them do as much as ForeFlight does. This is not an advertisement, but they should sponsor us. So you can find all the frequencies on ForeFlight. It's basically your chart. Back in the day, we had paper charts. We still teach paper charts, by the way. So you'll still see, this is exactly what a paper chart looks like. Obviously, it's zoomed in, but you'll see the name of the airport, the frequencies, the elevation. You'll still see all of that on a paper chart. So for Lincoln, the AWOS frequency is 12425. Again, I just called it on my phone because it has that capability for ForeFlight. And then listening to the weather, here's the information that we got. So 29 or 80 is the altimeter setting. The altimeter is what tells you your altitude. It means sea level, MSL. When you set 29 or 80, the altimeter should be within 75 feet of the field elevation. For Lincoln, the field elevation is 121. It says it there, and it also says it on the chart in italics, 121. So it's 121 feet above sea level. So if sea level is right here, Lincoln's right there. It's not very high. It's like that. If you go to Auburn or Truckee, Lake Tahoe, elevations, Auburn's 1,500 feet. I think Lake Tahoe is 5,000 feet or something around there. So elevation, gets higher, obviously, in the mountains. Go to somewhere like Colorado, you have airports that are at 10,000 feet. So 121, not a huge deal. It's basically sea level. 2980, you set the altimeter. It should read with close to 121. It should be kind of around whatever the field elevation is. If it's not, then you probably have either you have the wrong altimeter setting in or the altimeter is busted. And you would decide if you could fly by referencing that 91205 that we talked about last time, the regulations 91205, aka A tomato flames. It doesn't tell you the humidity, the voice doesn't, but ForeFlight does. Humidity is 18%. We kind of talked about the temperature dew point. It's a far spread, so it's obviously pretty dry air. Humidity is 18%, that checks out. Density altitude was 2,300. ForeFlight's more specific, 2,356. So density altitude is going to be a really big factor for you guys as it gets hotter. Because the hotter it gets, the higher your density altitude will be. And what your density altitude is, in layman's terms, is the altitude that your airplane thinks it's flying at. So you might be taking off out of Lincoln, which is an elevation of 121. Your airplane thinks it's taking off out of an airport at 2,300 feet. So your airplane's going to perform as if it were at 2,300 feet. That being said, 2,300 feet is not a big deal. It's not that high of an elevation. But it's not going to perform like it's at sea level. As you get higher in density altitude and just higher in altitude in general, the air gets thinner. When the air gets thinner, the engine does not perform as well. Just like your car, if you're driving your car in the summertime in Lake Tahoe, you notice your car doesn't perform as well. You kind of have to step on the gas for a little bit more speed. Usually, you can step on it just a little bit to get 65. If it's hot, you're in Lake Tahoe, you have to press on it a little bit more to get 65. So a little bit more power for the same speed that you're used to. Same thing with density altitude. Usually maybe you cruise at 2,300 RPM and you get 90 knots out of that. On a hot day, high density altitude, you might have to do 2,400 RPM to get the same speed. Because again, I think I kind of referenced this last time. If I were to fill this mug with air and cover it on a hot day, I only have I don't want to say only a few because air molecules are obviously very small, but I have relatively less air. If I were to fill it on a cold day with air, same cup, same volume, less air for a given volume if it's hot. Because again, the air molecules are spread farther apart. So if I have 2 boxes, I'll try not to get in everyone's way. If I have 2 boxes, let's just say they're the same size. Pretend they're exactly the same. If it's a cold day versus a hot day, the air molecules are very, very close on a cold day. On a hot day, it's more like this. Same box, same volume of air, or same amount of air going in, different volume. Make sense? Density altitude acts like that. So 2,300, not a big deal. But as you can tell, let's go see what Lake Tahoe's at. Lake Tahoe's at a higher elevation. I think it's South Lake Tahoe. So South Lake Tahoe's elevation is 6,268. Their density altitude right now is 8,000. So you're taking off out of an airport that's at 6,000 feet. Your plane thinks it's at 8,000 feet. Now things get a little squirrely because now your plane's like, I'm flying at 8,000 feet. Air is thin up here. But you're here on the ground. You're like, well, I'm at 6,200 feet. Not that big of a deal. My plane can do it. It's in the charts. I can see my takeoff and landing performance. What you're not taking into account is your plane thinks it's at 8,000 feet. Spoiler alert, the operating handbook for the Cessna 150 only goes to 7,500 feet. Now you're outside of the chart. Now you're a test pilot. So would you take off if you're a test pilot? In theory, no, I would not. I would not attempt that. That's why I tell people I would not take a Cessna 150 to Lake Tahoe. Especially even on if it's just a warm spring day in the afternoon, density altitude can get high up there. There's mountains over there that are 12,000 feet. So not only getting there would it be hard, but just getting out of it would be hard. So we don't care too much. I shouldn't say we don't care. We don't take into account enough density altitude at McClellan because it's at sea level pretty much at 77 feet elevation. It's got an almost 11,000 foot runway. Performance-wise, I think we're fine. But you start going to places like Lake Tahoe, even Auburn, which is only 1,500 elevation, the numbers start to be a little bit more worrisome. So density altitude, there's been a lot of accidents related to density altitude, pilots not taking into account the weather, how hot it is. Humidity also raises density altitude. So if you're, taking off out of Florida's pretty much sea level, but it gets humid over there. So density altitude can still be high over there just because there's a whole lot of water in the air. Water is lighter than air. So same effect on the engine, low performance. So again, I kind of switched up what we were talking about today because it's getting hotter. And not that I don't think basic weather theory is important, but I kind of want to get this in your head now as it gets hotter so that you're already kind of mentally prepared to deal with, hey, why is the plane not climbing very well? Why am I taking longer to take off? It's like, well, it's because it's getting warmer. Planes don't like flying in the hot weather. Cooler weather, they perform a lot better. So even though it's technically like flying season because the weather's nice, it's hot. It's getting hot in the afternoon. You also want to start taking into account your own personal hydration levels. We talked about PAVE, we talked about I'm safe last time. Hydration now comes into play. Have you been drinking water all day? And also, not just the day of, but if you're flying and you're talking about hydration, you need to be hydrating like 2 days prior as well. So you could be gulping water today, but if you didn't drink anything yesterday, your body's still catching up. So hydration's a big factor. Heat stroke, know your limits. If it's over like 105, I don't want to go. I don't want to fly. Just personally, it's hot. I'm sweating. The planes are like ovens when you get in there. It smells like sweat. I don't want to go. I'm not having fun. So like unless the plane has air conditioner, which most of them don't, that we're flying, probably not going to go if it's 105. And a lot of the time I'm taking off out of Auburn, so it's like I don't want to go. The plane doesn't want to go. Like I'm not about it. Okay.
Megan,
Yes.
There's paper charts. Where do you get these?
You can get them on Amazon now, actually. You can get them on Amazon. You can get them on sporties.com. They are updated every 56 days, I believe. So it's like you'd have to get a new one every 56 days. For training purposes, just get one and then just use that the whole time. It'll probably expire by the time you get to your check ride. That's fine. Your examiner knows you're using ForeFlight or whatever app you're using. They know you're using an app because that's kind of the way of the world now. By the way, it's called, the category of this app is called Electronic Flight Bag, EFB for short. So if you hear people talking about like, oh, what EFB do you use? They're asking like, do you use ForeFlight? Do you use Garmin Pilot? Do you use iFly is another one. iFly and Garmin Pilot, I believe, are Samsung Android friendly. So for the Samsung Android people, check those out.
Electronic flight what?
Electronic Flight Bag. Yeah. Cool. So that would be what it's like checking the weather like out of Lincoln or McClellan. Density altitude's big. So I wanted to kind of talk about that today just because it's getting hot. Does the temperature dew point spread thing make sense? Latifa, so the temperature dew point. The dew point is the temperature at which the air becomes saturated with moisture. So it can't hold moisture anymore, and you'll get visible moisture like fog. So if the temperature is far away from the dew point, then the air is relatively dry. If the two are close together or the same, you're probably going to get foggy weather. Cool, so that's that one. I think that's all I wanted to talk about in terms of when you get into the plane. This is what you're going to get down. This is what you're going to write down. I always recommend students write the weather down when you guys are first learning, just because it's good practice. It's good practice for you to interpret the information that you're given. ForeFlight tells it to you in plain English. You should still know how to interpret it yourself without depending on ForeFlight or whatever EFB you're using. 260 at 7. Wind's coming from that direction. You always want to take off into the wind. I shouldn't say always. There are some cases where I'm like, I'll take the tailwind. But planes are designed to take off into the wind. We're also designed to land into the wind. So if, for example, if the winds are 260 at 7, and maybe the runways that you have available are 25 and 7. So do you guys know where, are you comfortable about runway orientation? Do you kind of get the concept? Like how do runways get the numbers? Okay, so runways get their numbers based off of the magnetic direction that they're facing. So let's say that this is north, 360. This is east, south. So north is 360, east is 090, south is 180, west is 270. If I have a runway that's oriented for 7 and 2-5. When I'm lined up to take off on 2-5, I'm heading in a magnetic direction of 250. When I'm lined up on 7, I'm on a magnetic heading of 070. I'm going to the east. Does that make sense? So the numbers are based off of the magnetic direction that they're pointing in. So we said that the wind was coming from 260. So let's say this is the wind. This is the arrow is the wind. Am I taking off of 7 or 2-5?
Take on 2-5.
Correct, 2-5. Because if I'm lined up for 2-5 for takeoff, I'm in a direction of 250. The wind's at 260, so it's a 10-degree difference. It's basically a headwind. If I were to take off of 7, I got almost like a full tailwind. You don't want to take off with a full tailwind like that. Good? Does that make sense? Okay. So we check the weather. Primarily, you're checking what the winds are doing because you want to know which runway you're taking. Sometimes you'll get to an airport, like McClellan, for example, and it'll say winds are calm. McClellan has a calm wind runway. It's 16. So if the winds are calm, or even if the winds are variable, you would take off of 16. It's just the preferred runway. Not every airport has like a published preferred runway, but when you hang out at the airport enough, you kind of figure it out. So Auburn, for example, it's not official, but the preferred runway at Auburn is 25. And the reason for that is because if you take off of 7, there's a bunch of trees and hills over here. Kind of sketchy to take off into, especially at night. I would not do that at night. 25, it's a little bit more clear of obstacles, so we prefer 25. And also the winds tend to favor 25 anyway. Lincoln, the calm wind runway over there. Again, I don't think it's officially published, but the preferred runway at Lincoln's 15. If winds are calm, everyone's probably taking off and landing on 15. They have 15 and 33. Another thing with the runways is one runway or one strip is still technically considered 2 runways because you have 25 and 7, and they're always going to be in a 180-degree difference of each other. So 250 minus 180 is 070. So at McClellan, it's 34 and 16. 340 minus 180 is 160. So they're always 180 degrees from each other. Okay, now I think I'll just dive into the presentation I had originally planned. We'll talk a little bit about just basic weather theory, and it's a lot of information. So I'm gonna kind of just take my time. So the main cause of the weather is just uneven heating from the sun. That's it. And I do think that might be one of the questions on your worksheet. Uneven heating from the sun. It's mainly about heat transfer and temperature difference. Different temperatures cause different pressure levels. And basically, the atmosphere is always looking for equilibrium. So the way that the atmosphere equalizes is through wind. So high pressure will always go to low pressure. So you have a high pressure system and a low pressure system next to each other. That high pressure is always going to flow to the low pressure. That's where we get wind from. The air, the atmosphere is just trying to find equilibrium. It's trying to balance itself out. A good resource for weather is right here. AC stands for Advisory Circular. Advisory circulars are documents published by the FAA that provide some guidance and clarity on certain topics. AC 006 Bravo, I believe it was such a large document, they just created a little book out of it, which I'm pretty sure you can also get on Amazon. Or you can just get it online for free. So, do with that what you will. But if you look it up, it's like, I don't know, I feel like it's like 300 pages. You don't have to read all of it. But I would say like the first few chapters are good to get into because it does break down like basic weather theory. That's good to know. I feel like weather is not emphasized enough in private pilot because I don't know. I think there's an assumption that you're going to go get your instrument rating, and when you get your instrument rating, that's when people really dive into weather, because it's like, oh, now you can fly into the clouds. You can kind of take on more responsibility in regards to weather. But one of the main causes of fatal accidents is VFR pilots flying into bad weather, into clouds. So I feel like if there was a little bit more emphasis on weather for private pilot, people would be safer. So, part of it's your responsibility to do the studying, to watch the videos, but this is a good resource. I know reading's kind of dry, but also those AOPA crash investigations, they have a lot of weather-related accidents that are good to watch, because it just, kind of gives you the reality of the situation. But that's the basic cause of weather: uneven heating from the sun. High pressure always goes to low pressure. Atmosphere equalizes itself through wind. Okay, what's pressure? So just imagine that there is a large hand in the atmosphere pushing down on the air. That's what pressure means. There's a force on the atmosphere pushing down. Just imagine like a giant weight over the sky. If it's high pressure, then it's a really heavy weight pushing down on the atmosphere. It's pushing all of the air molecules closer together. If it's low pressure, then the weight's very light. Let's see, anything I want to talk about that? High pressure, in terms of weather, you'll normally get pretty good weather, but you'll get poor visibility because, pretend that there's a cap on the atmosphere, it's pushing down. If there's pollution in the air, haze or dust, dirt, all of that stuff, it can't lift because it's being pushed down. So we get hazy days. Bless you. What was the altimeter today? It was 2980. That's relatively okay. We measure pressure primarily in inches of mercury. So primarily, standard pressure at sea level on a standard day is 2.9 or 9 or 2, and that's in inches of mercury. So your altimeter setting is giving you the pressure level outside. So we said 2.9 or 8.0 today based off of Lincoln. So it's relatively low pressure because we compare it all to 2.9 or 9 or 2. So anything below 2.9 or 9 or 2 is relatively low pressure. Does that make sense? Another unit of pressure is millibars. I'm not going to get too deep into that, but millibars is another way of measuring pressure. And if you're doing millibars, the standard is 1013, and I think it's M with a capital B. I think that's how you write it. 1013 is the standard pressure in millibars. I'm telling you that because there's something called a prognostic chart that we're going to kind of dive into, and you're going to see numbers that look like that. So 1013 is the same thing as 2.9 or 9 or 2. Standard pressure at sea level. So pressure is like the weight of the atmosphere. Pressure variations. Pressure varies by altitude. If you get higher altitude, lower pressure. Higher temperature, also lower pressure. Water vapor. Water is lighter than air, so lower pressure. Same thing. You can read more about pressure and then the advisory circular. If you have low pressure, you'll also get clouds with more vertical development. So those big puffy clouds, they can only form in low pressure. If it's high pressure, then you'll get like stratus clouds, like those very flat clouds. You can get fog that way. Because again, the moisture can't lift. So it lifts up until the cap and then it just spreads out. And that's why you get the flat clouds. High pressure, good weather, poor visibility. It's relatively stable. Low pressure, great visibility because all that pollution can lift and rise, but you might get bumpy weather because you get more vertical development. And that's kind of when we might, get thunderstorms. Which, am I talking about that next? Nope, not yet. Okay. Okay, we talked about density altitude a little bit. We'll get a little bit more into it, and also something called pressure altitude. So pressure altitude is just, if you go into the airplane and you set the altimeter to 29 or 9 or 2, whatever it reads, that's your pressure altitude. That's just the pressure of the air around you. And there's different ways to figure out what pressure altitude is. I prefer the way through the formula. There's also a chart that you can just look up online, pressure altitude chart. I don't personally like it, but if you're more of a visual person, that might work better for you. I'm a little bit more analytical, so I kind of like the math, which is surprising because I hate math, but this one makes more sense to me. So if I wanted to find the pressure altitude, let's say based off of today at Lincoln. So Lincoln, the altimeter setting was 2980, and the field elevation was 121 feet. So if I'm going to take this formula to find pressure altitude, what I'm going to do is I'm going to do 29 or 9 or 2, because that's standard pressure, so you're always going to include 29 or 9 or 2, minus the current altimeter setting, which is 29 or 80, times that by 1,000, and then you add the field elevation. So, can someone do the math for me? Is that 0.12? Okay. So 0.12 times 1,000 plus the field elevation. Is this 120? Do we know off the top of your head? Okay. 120 plus the field elevation, which is 121. 221. Okay. Pressure altitude is 221. Did I do the math right? 241. Oh, thank you. I was doing so well. 241 is the pressure altitude. Okay. So if you were to set the altimeter at Lincoln to 29 or 9 or 2, it should read roughly 241. Okay, great. Why do we care about pressure altitude? So we can get density altitude, because that's really what we care about. I will say, I do think the operating handbook for this plane, the performance is based off of pressure altitude. So you do care about it for performance, but then there'll be like a note underneath that chart, and it'll say, increase everything by a certain percent for every degree change in temperature. So, performance starts are in pressure altitude, but then it depends on the temperature. So we really care about density altitude, because density altitude is the altitude your plane thinks it's at. The more formal definition is density altitude is pressure altitude corrected for non-standard temperature, which it's non-standard because it's hot outside. So at sea level, your standard pressure is 15 degrees Celsius. If it's a normal day at sea level on the beach, it should be 15 degrees Celsius. The pressure should be 29 or 9 or 2. These are the standards. It's not standard though. It's hotter than normal. It's 33 degrees Celsius at Lincoln. So it's a lot hotter than standard. There's another formula. Do you guys want to go into it? Or do we? Okay. I know it's numbers. I know it's math. I know it's not fun. All right, so let's remember that pressure altitude was 241. I'm doing a new page. Okay, it's 241. So density altitude equals pressure altitude, which is 241, plus 120. I don't know where they got 120 from. That's just the number. It's always going to be 120. Times the outside air temperature. That's what OAT means. And it's always going to be in degrees Celsius, minus the, what does the I stand for? ISA, it means standard temperature. I can't remember exactly what it stands for. I feel like it's like isobaric standard atmosphere. But just ISA, degrees Celsius, is the standard temperature for that airport. So it's 241 plus 120 times the outside air temperature was 33 degrees Celsius. And then Lincoln's pretty much at sea level, so we're going to use the standard 15 degrees Celsius.
Is this international standard atmosphere?
Thank you. Yep, that was wrong. International Standard Atmosphere. That's what it said? Okay, cool. So that's what ISA stands for. 241 plus, who wants to do the math? 120 times 18. Thank you. Okay, and then 241 plus, what's 120 times 18? I'm at a loss. 120 times 18. 2,160. And then what's 241 plus 2,160? What is it? 0, 1. Okay, density altitude. Obviously, ForeFlight already told us, so we did all that work for nothing. However, you should still know how to do this, just in case. Okay, so I think Lincoln said 2,300. We got 2,401. Okay, relatively the same. 100 feet's not going to make a huge difference. 2,401. That's density altitude. We care about pressure altitude because the POH performance is in pressure altitude, but we really care about density altitude because that's what the plane thinks it's at. It's 2,400 feet. Again, I will send this presentation to you guys. I'll probably do it over the text message, which I emailed I shared the Google Drive with you guys. I don't know if you got it with the press. Okay, I couldn't email the document because it was too big. But I might try to send it through WhatsApp. Maybe that'll work. Because there's just some links for you guys to kind of check out. Okay, fronts and air masses. So an air mass is just a big body of air that has relatively the same, what's it called? Uniform temperature and humidity. And there's different types depending on the region. So there's Arctic, there's polar, and there's tropical. You don't need to worry too much about that. All you need to know is what is an air mass, or what's a front, and what is an air mass. Air mass, you have one air mass over here that's hot. You have another air mass over here that's cold. A front is the boundary between the two. And if it's a cold front, that means that the cold air mass is overtaking the warm air mass, which is usually what happens because cold air moves a lot faster than warmer air. So usually cold fronts are are usually the ones that happen most often. That being said, we do get warm fronts once in a while. So the front is a boundary between two air masses. And we care about fronts because they will tell us what kind of weather we can expect for the next few days, depending on what kind of front it is. So, talk about prog charts, prognostic charts. That's what this is. So here's the legend, what the symbols mean. Cold front is a blue line with blue triangles. Think of icicles, cold front. And then the warm front is red with half circles. Think of the sun, it's warm. A stationary front is a combination of the two. And then a occluded front is a combination of the two, but it's purple. So a cold front, you have a cold air mass overtaking a warm air mass. If this is the warm air mass, this is the cold air mass, it overtakes it like a plow, like a snow plow. It shoves it up. If it's a warm air front or a warm front taking over a cold front, think of just like, I don't know, like a big heat pad. It kind of just like lazily droops over the colder air mass, and that's how a warm front happens, is the warm air is on top of the cold air. Cold front, cold air is plowing through the warm air front, the warm front. Stationary front is a front that's kind of both. So you'll usually get a stationary front when you have either a strong warm front or a weak cold front. Because usually you get the cold front because usually the cold air overtakes the warm. But sometimes you get stationary fronts. We get those a lot in California. We get those a lot in the fall and in the spring. So neither air mass is overtaking the other. They're kind of just like at a stalemate. And then you have an occluded front, which is a cold front overtaking a warm front or a stationary front. So you've already got a warm front over here. Now a really strong cold front's overtaking the warm front. So now you get all this mixed weather in an occluded front. Cold front, to be super simple, cold fronts are usually bad weather. It's usually where we get like thunderstorms and rain. Because you have a cold air mass, you have low pressure, you get a lot of lifting action, a lot of moistures in the air, you get clouds that form. Warm front, typically pretty good weather, warm weather. You don't have a lot of instability, so you don't have a lot of clouds forming. And if you do, they're super hazy or they're very flat and stable. If you get a stationary front, you kind of get a mix of the two, a cold front and a warm front. So it'll probably rain, but it'll be like a steady rain. It won't be like a super showery, unstable rain. And it'll probably linger here for a few days. Because usually the cold fronts, they'll blast through California in like a day. Stationary fronts, you'll get rain, like drizzle, for like 3 days at a time, if not more. So if we ever have lingering rain, it's probably a stationary front, as long as it's not like unsteady and showery. If it's showery, it's probably a cold front, where it's just like it's suddenly raining and then it stops and it's suddenly raining again. Occluded front, you get pretty bad weather as well, because it's a cold front overtaking another front. So you'll get a lot of thunderstorms, lots of instability, just bad weather, lots of rain. So cold fronts and occluded fronts, not great days to fly. Questions on prog charts. And they'll always display it over the whole continental US. You can find these on ForeFlight. You can find these on another website called aviationweather.gov. And basically, it's just giving you a general overview of what the pressure levels are in the United States, what fronts and systems are moving through. So like right now, well, not right now, but whenever I took the screenshot of this prog chart, you have a cold front, but then it kind of becomes a stationary front over on the East Coast, and a lot of rain, which makes sense because it's a cold front, but then also the stationary front. You can still get rain with stationary front. It's just typically not like super unstable or showery. All the H's, those are high pressure. The L's are low pressure. What? I don't know why it stopped, but we'll try again. Okay. Millibars, why I brought that up. They're really small, but do you see these black lines? Those are called isobars, I-S-O-B-A-R-S, isobars. Those are lines of equal pressure. So this whole line is the same pressure level, which is 1024. That's in millibars. So remember the standard millibar pressure? Do you guys remember that? Yes. So standard pressure in millibars is 1013. This is 1024. So it's high pressure along this line right here, this isobar. Another thing is if you see isobars that are really close together, those are lines of equal pressure, but they're different pressure. So you have like a line of 1024, you have a line of like 1018, you have a line of 1013. They're close together. Remember, weather's always looking for equilibrium. So you're going to get a lot of windy conditions if you're in an area where the isobars are close together. Because you have different pressure levels that are fighting to kind of overtake one another, and the high pressure is always going to flow to low pressure. It's trying to reach equilibrium, so if they're next to each other, the wind's like, oh my God, it has to scramble. So you get windy conditions. In this case, like this line is far away from that one, so it's probably not super windy over there. But like up here, looks pretty windy. Different pressure levels close together. And in the US, we usually, at least in California, we usually get the weather flowing from the west to the east. Because what's to the right of us? Or your left? What is this? Ocean. Yep, that's where the weather comes from, for the most part, in California. So if we're getting a cold front, it's coming from the coast. So you're going to have it moving from west to east for the most part. Okay, thunderstorms. You need 3 ingredients for a thunderstorm: instability, a lifting action, and moisture. Instability, so think of low pressure. If there's low pressure in the atmosphere, unstable conditions, because the air is just, again, trying to reach equilibrium. With low pressure, moisture and air has the ability to lift. So now you have moisture that's lifting. If you have like a little parcel of air and it's full of moisture, as it lifts, the air condenses, the water condenses, and then it heats up again, and then it continues lifting. So the whole condensation process keeps continuing. The condensation, the energy from the condensation warms up that air so that it can continue lifting. So as it condenses, you have gas turning into like a visible moisture, and then it continues lifting. So that visible moisture forms here, and then here, and here, and here, and it forms a cloud. The big puffy ones are called cumulus clouds. And now if you add moisture into the mix, you can get a cumulonimbus cloud, which is just a cumulus cloud filled with rain. So you have these 3 ingredients, you're going to get a thunderstorm. If you don't have one out of these 3, then you're not getting a thunderstorm. All of these have to exist. The general rule of thumb for thunderstorms for general aviation is to clear them by 20 miles when you're flying. So if there's like thunderstorms in the vicinity of an airport, you probably don't want to go to that airport. But yeah, rule of thumb, 20 miles. Then you also have wind and wind shear. So that is definitely a product. It doesn't have to just form in a thunderstorm, but if you have a thunderstorm, you probably have wind shear. So wind shear is just a sudden change in direction or velocity of the wind. So if you're on a landing and you have a 10-knot headwind and suddenly it becomes a 10-knot tailwind, that's wind shear. And it can be problematic because it'll change. Your plane's going to react to that wind shear aerodynamically, and it might not be favorable because, again, we like to take off and land into the wind. So if suddenly it becomes a tailwind, plane doesn't like that. Usually a tailwind will make your nose drop down. And if you don't know how to react properly and how maybe to add power or to add power and pull back up, it might put you in a kind of a squirrely situation. Microburst, that's just an extreme downdraft within a thunderstorm. So downdrafts are just a very strong downward motion of the air, and it's strong enough to where the plane cannot outclimb it. Because it can be as strong as, I think with microbursts, I think the number is that it can be as strong as 6,000 feet per minute. Our planes mostly, on average, the Cessna will climb at 500 feet per minute. So we definitely cannot outclimb that. Turbulence, irregular motion of the air. There's different kinds of turbulence. There's mechanical turbulence. So if you go to Auburn, an airport like Auburn, there's a lot of hangars that are built really close to the runway. As the air flows through the hangars, it'll change the direction of the wind. So the wind might be coming from the south, but by the time it's done going through the hangars, now suddenly it's coming from the west. So mechanical turbulence, it's just terrain or other obstacles, they change the direction of the wind. You have wake turbulence behind airplanes. That's more of aerodynamics, so I won't get too much into that. But, air acts the same way as water. So you think of a boat driving through a lake, it generates a wake behind it, right? It has like waves behind it. Same thing with airplanes, especially jets. So you want to be careful landing and taking off behind jets because the wake turbulence from a jet can flip that plane over. Does our concern as pilots of wind shear make sense? Any questions on that? There's two main types of wind shear. There's a gain shear, like you're gaining something, or a loss shear. Gaining in terms of you're gaining a headwind, like maybe you had a tailwind, suddenly it's a headwind. Not so bad to deal with. A loss shear, you're losing the headwind and you get a tailwind. That's a little bit more dangerous. An example would be if you're flying on a base leg. So let's say we're landing on 2.5. So the wind's coming from this direction. So here's your downwind leg because you're flying downwind. And then it's going to get cut off. But when you're squaring it up, like right around here, and you're going perpendicular to the runway, that's your base leg. So sometimes you're going to land in a crosswind. That's just a fact of life. So let's say that you have a crosswind. Now we have winds coming from the north. So ignore that. Now you have winds coming from the north, but we're still landing on 2.5. Because if I'm on a base leg and I have a crosswind when I turn final to land, at least on my base leg I have a headwind. That's not too bad. A headwind, it'll slow you down a little bit as you're moving across the ground. It'll give you a little bit more time to set up for your final turn. But now, if you have wind shear, suddenly that headwind becomes a tailwind. Now you're blasting through your base leg and you're going to end up overshooting your base leg. And now you're over here, even though the runway's right here, but you weren't able to prepare for that because you had a headwind. So like you were expecting the headwind. But when it became a tailwind, it just pushed the plane over past the runway. And what could end up happening is in a desperate attempt to turn back around to square up on a final approach, maybe you bank too steep. And maybe because you're banking too steep and you're close to the ground, you're like, oh God, I don't want to be that steep. And you use the rudder, the opposite rudder of the turn to get out of that steep bank. But when you're landing, you're going a little slower than normal. Now you're in a cross control because you have left aileron, left bank, and right rudder. You're exposing more of the surface area of the plane to the wind now. You get unstable, you can stall the plane. You're close to the ground. You're probably no more than 500 feet above the ground. You don't know how to recover from a stall. That plane's going down. So, worst case scenario, your wind shear becomes a tailwind. You overshoot. You try to correct in the wrong way. Stall the plane. You crash into the ground. It's dark, but we're going to talk about it. So that's the danger. Worst case scenario.
In that case, you would just go around. Right?
Go around. Thank you. Yep. Oh, it has sound to it. I didn't know that. Okay. Yeah. That's nice. Okay. So atmospheric stability, some indications of stability. This video is obviously, it's not very stable outside. It's very windy. It's rainy. The trees are moving. Can I turn that off? Okay. So if I were to go outside or if I were to look at the weather, some indications of stability would be the clouds. If I go outside and I see a big old cumulus cloud over the airport, I can kind of assume it's probably not super stable outside. This picture, for example, they're a little puffy, but they're pretty flat. So I would argue that it's probably relatively stable on that day that the picture was taken. Precipitation, if it's like a steady drizzle throughout the day, it's probably pretty stable outside, even though it's raining. Rain does not necessarily mean instability. But if it's like showering, like in this video, like that, it's probably unstable. Lots of moisture in the air, lots of wind. Again, wind is just the atmosphere trying to equalize. So the stronger the wind, it's probably because there's a stronger difference between pressure levels. And so the wind's going faster. And then the lapse rate. So the temperature of the air, it cools down 2 degrees Celsius for every 1,000 feet. So at sea level, we started at 15 degrees Celsius. As you go up 1,000 feet in elevation, it'll become 13 degrees Celsius. Go up another 1,000 feet. Now you're at 2,000 feet elevation. Now it's 11 degrees Celsius. Air cools down as you get higher, 2 degrees Celsius. I think that's roughly like 3.5 degrees Fahrenheit. If it's cooling down faster than that, the air is unstable because you get a more rapid temperature drop. It's just indicating that there's just instability in the air. So if it's cooling down 3 degrees Celsius or 4 degrees Celsius, the air, you can expect the atmosphere is pretty unstable. What causes changes in stability? Just because the temperature changes for different reasons, mainly temperature changes with height. So again, with the lapse rate, as you get higher, it should relatively cool down by 2 degrees Celsius. If it's more than that, you can count it's probably unstable.
You would notice that with obviously some sort of thermometer inside. As you're going up, you're noticing it's dropping, and you're like, okay. At that point, you'll be like, okay, maybe I shouldn't.
I don't want to say like you shouldn't go. You know, there's different factors that come into play, like when you're trying to make a go no go decision. So like your first factor, first of all, would be yourself, you know, and your familiarity with the airplane. But just because it's unstable doesn't mean you can't go. If it's unstable, it's probably going to be windy. So that would be like kind of your first hint of like, maybe I should consider like not going. So if you're taking off out of McClellan and it's really windy and you notice the lapse rate's unstable and it's like a 10 knot crosswind, that's kind of like the more tangible evidence of like, maybe I shouldn't go today. If you're solo, you know, when you guys solo for the first time, your instructor is going to give you limitations and it's probably not going to be more than like a 7 knot crosswind. So if it's 10 knots, legally you just can't go because you're subject to whatever your endorsement says for your solo. So yeah, if it's a 10 knot crosswind and you've never done a 10 knot crosswind by yourself, or your CFI said you can't do that, then you can't go. Obviously, as you become private pilots and you're no longer subject to the limitations of those endorsements, it's really just up to you to determine if you go or not. So that's where something called personal minimums come in. A lot of students, my students that have, you know, soloed and passed their check ride and now they're private pilots, they will just use the endorsement limitations I gave them to start out. So even though they're private pilots, they passed the check ride, all of that, I don't let anyone fly solo with more than a 7 knot crosswind, maybe 6 knots, depends on the person. They're a private pilot, they still won't take off if it's more than 7 knots. If it's more than 7 knots and they want to expand, you know, their abilities, they'll be like, hey, Megan, can you go fly with me? It's a 10 knot crosswind I want to try. For sure. We do that. Don't ever try it by yourself the first time. Go with the CFI, go with a seasoned pilot who's comfortable with that. And you can expand your personal minimums that way. That's totally fine. But like if it's by yourself, it's like you gotta weigh that responsibility of like, well, my personal minimum is 7, today it's 8. Okay, that's a black and white reason to not go. Some people are like, oh, it's kind of a gray area though, because it's like it's an airport I'm familiar with. No, not really. Whether or not you're familiar with it or not, that's your 7 knot crosswind limitation. That's your limitation on a good day, on the perfect day, at an airport you're familiar with and an airplane you're familiar with. It should only get smaller from there. So let's say you go to an airport you're not familiar with. Okay, maybe it's not 7 knots, maybe now it's 5 knots. I'm not taking off if it's more than 5 knots because I don't know this airport, I don't know the terrain, maybe I don't know the airplane as well. So it should only go smaller, it can't get bigger the same day. Clouds, I won't spend too much time on clouds, but there are 3 main types. There's cumulus cloud. This is all, I think, Latin. That's where the words come from. Cumulus clouds, a lot of vertical development, instability of the air. That's how they develop because you have that parcel of air, that moisture. It's just lifting because it's low pressure. So it's lifting, it's condensing. That energy from the condensation causes it to warm up again. So then it lifts even further. And it lifts all the way until it can't because it cools down too much. And my Mac's gonna die. So the cumulus clouds, they're only gonna top out when it gets too cold for them to further condense. And the energy from the condensation is not enough to warm it up. I probably should have checked. Oh yeah, there's an outlet, that's good. Oh God. That was scary. Please don't do that. Stratus clouds, flat, stable, smooth air. If you're flying through these clouds when you get your instrument rating, not right now, But when you get your instrument rating, eventually, if you want to, you can expect icing in cumulus clouds. You can probably expect icing in a stratus cloud. Fog is a form of stratus cloud. It's just a low stratus cloud, so fog is considered stratus. You can get icing in fog. Cirrus clouds, I don't know the scientific term, so I said wispies. They're wispies in the air. Usually smooth air. Cirrus clouds are usually pretty high, so you're probably not going to fly into one in a 150, but they're actually made of ice, so you're not going to accumulate ice because it's already there, so it's not going to like stick to the plane or anything. Okay, weather regulations. So how are we on time? Okay, we're pretty good on time. How are we doing? I know it's warm, and I get sleepy when it's warm. So I understand. I get that. Same. I've thrown math at you. I've thrown weather at you. I know it's like this is a lot of material. 91-155 is a regulation I would get very familiar with, or at least know where it is in your FAR AIM, whether it's like a physical book or whether you're on ForeFlight or just you have a FAR AIM on a digital version. I think with your Sporties account, you should get it free access to a FAR AIM. FAR means Federal Aviation Regulation, and then AIM is Aeronautical Information Manual. So when I say FAR AIM, it's because those two are combined into one book. So because you're private pilots, you are subject to something called VFR, weather minimums, visual flight rules, weather minimums, and it depends on the airspace that you're in. So if you're operating out of McClellan, as a reminder, McClellan was surrounded by a dashed magenta line. I'm using so much paper. So McClellan on the chart looks like this, surrounded by a dashed magenta line circle. On the VFR chart, like on ForeFlight, the airports are surrounded by like either like a magenta line or a blue line, and it's either dashed or it's like a fuzzy, what's it called? Like ombre line. And those all depict different airspaces. So McClellan specifically is in a class Echo airspace. So there's Alpha, Bravo, Charlie, Delta, Echo, and Golf. I think in other places in the world, there's also a class Foxtrot. I don't believe we have that in the United States. You'll primarily be flying in Echo and Golf. Those are the main airspaces you'll be in. And it's the reason why a lot of people who want to learn how to become a pilot from out of country, they come to the United States to learn. Because we have a lot more free airspace than a lot of other countries, like specifically Europe. So for example, Class Alpha, you're never going to go into Class Alpha because it's IFR only. So unless you get your instrument rating and you get a plane that can go that high, you won't be in Class Alpha. So there's no weather minimums for Class Alpha. That's why it's not on here, because it's instrument rated only. Our Class Alpha starts at 18,000 feet, aka flight level FL 180. In some places in Europe, I believe their Alpha starts at 4,500 feet. So it's a lot more limited over there. That's why they come over here to learn how to fly, because we have a lot more Echo and Golf, just free places to go. Again, I won't go too deep into this because it's kind of heavy, but you'll primarily be in Echo and Golf. Echo, your weather minimums, you need at least 3 statute miles to be considered VFR. Anything below that is no-go. And you need a certain amount of cloud clearance. So 152, there's a memory device for weather minimums. It's called 3 152s, because a 152 is a type of airplane. So for Echo, it's primarily 3 152s. You need 1,000 feet above a cloud. You need to be 500 feet below a cloud. And if you're flying like in between 2 clouds, you need to have 2,000 feet of clearance on either side to be legal. And to be honest with you, what does that look like? It's kind of just like you fly with your CFI. You fly with your CFI, and your CFI would be like, yeah, looks like about 500 feet. You're probably fine. That's probably how it's going to go. But also, you'll be flying, and you'll learn how to check the weather a lot more accurately, and you'll see what the ceilings are reported. So they'll be like, okay, the ceilings are reported at 3,000. Okay, well then don't fly at 3,000. Fly at 2,500 to be 500 feet below what the reported ceilings are. A lot of the time also, if you're talking to air traffic control, pilots are pretty good about giving them reports. So usually, like if I'm flying with a student and I'm in an area that's not necessarily doesn't have an airport beneath it that would report the weather, I'll be at an altitude, and if I'm over it, or if I'm under it, or if I break out of the clouds, if I'm flying on an IFR plan, I'll be like, hey, I broke out of the clouds around 4,000 feet. Just to let them know, hey, the tops of the clouds are 4,000. The bases of the clouds are 3,000. So I'll let ATC know, so that way they can let other pilots know. Be like, hey, yeah, the tops are reported at 4,000, and the bases are at 3,000. So then everybody who's VFR knows, okay, I can't go to 3,000. I have to stay at 2,500 if I'm in Echo or in any of the other ones that are relevant. So, and then it changes when you go into Golf, Bravo. Charlie and Delta are the same things, 3-152s. So Charlie, Delta, 3-152s, Echoes, 3-152s if you're below 10,000 feet, which you probably are. Once you get up higher in Echo, it actually increases. You need more. You need 5 statute miles now. You need 1,000 feet below clouds, 1,000 feet above, and 1 mile in between, horizontal. And the reason for that is because when you're up higher, you're dealing with faster aircraft. There's a lot of jets up above 10,000 feet. You need more clearance from them. You need more reaction time. So 3 miles is not enough if you have a jet that's going 300 knots. So as you go higher, you need more clearance. Because a lot of those jets, they might be flying in the clouds because they're flying instrument. And if you're flying above a cloud and you're only 500 feet above it, and you got a jet that's about to break out, 500 feet's not a lot of time to get out of the way. And then Class Golf is a tricky one. Class Golf trips up everybody. It still trips me up sometimes because it changes not only by altitude, but it changes if it's day or night. For the most part, you'll be dealing with, at least in the Sacramento area, you'll normally be dealing with Class Golf up until 700 feet AGL, and then it becomes Echo. So you're primarily going to be flying around Echo. Golf just exists where everything else doesn't. So you can find this in 91-155 in the regulations, or you can also find it again in Chapter 7 of the Aviation Information Manual. Kind of talk about establishing personal minimums. This is something that you'll kind of do with your CFI, because your CFI is going to know your abilities. So there's an article on AOPA, which again, you'll get the link when I send you guys this presentation. There's also a personal minimums contract that AOPA provides that you can print out and fill it out with your CFI. I would do that right before you solo, and also have it before your check ride, because examiners are very impressed if you have a personal minimums contract written down that you've signed, and you can hand to them and be like, these are my personal minimums. I will not fly if these are not met. And then your examiner's like, cool, great. You obviously are organized and you're a safe pilot. So again, that's kind of something more that you'll talk about with your primary CFI, because they trained you and they've seen your capabilities. So they'll be able to judge hey, can you do a 6-knot crosswind or a 7-knot crosswind? Okay, METARs versus TAFs. So on ForeFlight, when we looked at Lincoln and McClellan, you saw that there was also something called METAR. METAR is reported every hour. It's just a type of weather report, and what it stands for is up there. It's meteorological aerodrome reports. Every hour, you know how there's a forecast? These are considered nowcasts, hey, here's kind of what's happening now. And they're not the same as like an AWAS, which is what we listened to, but they are formatted pretty much the same way. So an AWAS is every minute, and ASOS is also every minute. METARs are every hour. So if I go to ForeFlight, we're at Lake Tahoe. There's the METAR. And this was given at 4:53. It's 5:19. 27 minutes ago. Yeah, it's like every 55 minutes, every hour. It's formatted pretty much the same way that like you would listen to the AWAS, but it's just a different report. And then you have a TAF. Not every airport has a TAF. So if your airport does not have a TAF, it's just going to pull the nearest TAF that is available. So like Auburn, for example, does not have a TAF, but it'll pull the TAF either from McClellan or Beale. You want to be careful with that because Auburn, again, is at 1,500 feet elevation. If it pulls the TAF from Beale, Beale is pretty much at sea level. Weather changes based off of elevation. And over the mountains generate their own weather. I don't know what the mountains are doing. It's different. So the Beale TAF or the McClellan TAF is not really relevant for Auburn. So honestly, I wouldn't even really consider it. But Lake Tahoe has its own TAF. So TAF is more of a forecast, and a TAF is reporting the weather within a 5 nautical mile radius around the airport, and it's terminal aerodome forecast. It's aerodome or aerodrome. It's the weird word. It just means airport. It's a forecast, and it's issued about 4 times a day. And it's good for a 24 to 30 hour period. So that's why it's a forecast, because it's kind of more in the future. Right now at 5 p.m., it's forecast to be VFR. The winds are variable at 3, over 6 miles visibility, and the clouds are few at 10,000. So there's a few clouds in the sky at 10,000 feet. And then tomorrow at 11, it's still VFR, but now the winds are 030 at 7. The visibility is +6, and the clouds are at 8,000 feet, few, and then scattered at 25,000 feet. And then tomorrow at 5 p.m., a new TAF will be issued. So that's more of a forecast. The METAR is a nowcast. Questions on METARs and TAFs? TAFs are issued by humans. METARs are automated. Also, not every airport even has a weather reporting facility. So what you would do is you would just find the nearest airport that did have one, and you would use that to be relevant. You know, take into account the terrain around it. But for example, I know for McClellan, Willows is a cross country that a lot of CFIs do. Willows does not have a weather reporting facility. I believe the nearest one is Chico, so we use Chico. We good? Move forward? Okay. Prog charts, we kind of already talked about it, but here it is again. They're forecasts. They show the position and characteristics of the pressure patterns, fronts, and precipitation at specific times. And usually when you're looking at the prog chart, you'll have like this legend below. So you don't necessarily have to memorize this. It's usually included. There's an included front, there's your cold front, and then here's your stationary front. But no precipitation, because otherwise you'd have like a radar return of green. If it's light green, it's a chance of rain. If it's dark green, it's likely that there's rain. Thunderstorms, it will usually be like a dark red or like that red hash lines. And prog charts are really just big picture things. They're not necessarily local weather, but just a big picture of what you can expect. The GFA tool, I will show you just a little bit. This is on a website called aviationweather.gov. I don't want to dive too much into it, but it's a really good weather resource. aviationweather.gov. So I would go to, I think it's under products or tools. So under weather, if you just click onto one of these, it'll just take you to the GFA tool. So here it is. It has different layers, and the layers are all over here. So right now, I could do the METAR stuff. Flight category, it'll tell me if it's VFR or IFR. If it's green, it's VFR. If it's red, it's IFR. If it's blue, it's VFR technically, but barely. Just different map options. Like what I like to do is I like to turn on the airports, show the IDs.
Purple dots.
Purple dots are low IFR. So, okay, so here, ForeFlight and aviationweather.gov, they do something that's kind of confusing. Let me see if it'll let me click on it. Okay, so there's two categories that you can fly, IFR and VFR. IFR is instrument flight rules, VFR is visual flight rules. ForeFlight and aviationweather.gov, they split it even further into four. They say VFR, marginal VFR. So marginal VFR is still VFR. It's just barely. IFR, low IFR. Low IFR is like it's real IFR. Those aren't legal categories. It's just IFR and VFR. But I like how they do it because I think it makes it easier to make your go or no-go decision a little bit more objective, because then you can split it down further and be like, I will not take off if it's marginal VFR. I'll only take off in VFR. And then IFR, for me personally, because I can fly IFR, I don't take off if it's a low IFR. So it kind of makes it a little bit, it splits it into more nuanced details that make it a little bit easier for you to decide whether or not to go. It makes it just, again, a little bit more black and white, because it's like, well, I could take off in VFR for sure, but if it's 3 miles visibility, that's not a lot of visibility. It's still VFR though. So that kind of makes it hard, like, well, it's VFR, so I can go. But if it's 3 miles visibility only, that becomes a marginal VFR. So then you could be like, oh, it's marginal, I'm not going. So that's what those mean, but I don't want it to confuse you, because legally it's just IFR and VFR. But the GFA tool is really cool because it can go all the way to 18 Zulu, so all the way to tomorrow at 11 a.m. So it can go pretty far in the future. It includes a lot of different layers. You can look at like the thunderstorm layer. You can look at the clouds and ceiling layer, visibility layer. There's a lot of different information that you can find on this. So I like to use this a lot if I'm planning a flight like 2 days from now, because it kind of tells me the trends. And then again, I turn on the airport IDs because I don't have it exactly memorized where all the airports are, like their exact location. So if you turn on the airport IDs, you can actually see, like, if I'm taking off from McClellan and I'm going to Monterey, there's KMCC, that's McClellan, and KMRY, that's Monterey. So now, like, I know where they are, and I know, like, what the weather is specifically. So this is a fun tool to play with.
And why a lot of them start with a K?
So not every airport. Most airports in the United States, they start with K, just to represent that this is an airport in the continental US. Mm-hmm. Not every airport does. Like, for example, Petaluma is Oscar 69er. I don't necessarily know why that one doesn't have a kilo in front of it, but like McClellan has a kilo, Auburn has a kilo. If you go to Alaska and Hawaii, it's a P. So it'll be, what's a airport? Anchorage in Alaska. I think it's ANC, so it's PANC, just to designate that this airport's in Alaska or Hawaii. I think in Canada it's a C. I'm not for sure. I know, like, so with airplanes, all of our airplane tail numbers in the United States begin with a November. So it's November 7243 Foxtrot, November 61329er. Go to Canada, it's a C. So sometimes you'll see planes that have like a C instead of an N. That's from Canada. I don't know what they do in Europe, but yeah, November is United States, K is the continental United States. I think that's the only ones that I know of. Kilo, Papa, and Charlie. Yeah, that's the GFA tool. It's the Graphical Forecast Aviation. There's too many acronyms. I obviously don't know all of them. Too many. We kind of dove into ForeFlight. Again, low IFR is pink or purple. IFR is red. Marginal VFR is blue, and straight VFR is green. So they classify VFR, green VFR, as a ceiling of greater than 3,000 feet and visibility greater than 5. Marginal VFR is 3,000 feet and visibility 1,000 to 3,000 feet, and or visibility 3 to 5 miles. So if it's like 4 miles or 3 miles, it's considered marginal. You could use that as a personal minimum and say, okay, I'm not going because it's marginal. And then IFR ceilings that are less than 1,000 feet, visibility is 1 to less than 3 miles. Low IFR is a ceiling less than 500 feet and or visibility less than 1 mile. So I personally do not fly in low IFR. When you're not sure, like there's a lot of weather products to look at. It's really hard to determine like how exactly to interpret all of it. So when in doubt, you can talk to a real life person who will interpret it all for you and kind of explain it to you. He or she is called a weather briefer. The phone number is 1-800-WEATHER-BRIEF, and it's like this. It's 1-800-WX-BRIEF. And I think nowadays you have to go onto their website first and create an account, because then when you call, you'll have your phone number on the account, and they'll, I think you can put like all your information, like the plane that you usually fly, your certificate number, all of that stuff. So they already have your information. If you don't make an account, I think you can still talk to them, but it takes you through like a long menu where it's like, if you created an account, you would avoid all of this. So it's okay, go create an account. You can request 3 different types of briefings from a weather briefer. You can, if it's anywhere between 6 hours and 2 days before the flight, you can ask for an outlook briefing. They'll just give you like a vague overview, a general overview of what weather you can expect that far in advance. A standard briefing is if you're going to take off within 6 hours. And an abbreviated briefing is like as soon as practical before flight. If you already got a standard briefing, but you want an update, like, hey, is there still a thunderstorm over Monterey right now? You can call for an abbreviated briefing, and they can just tell you specifically about that information that you request. Advisor circular, remember advisor circulars, 9192 will take you through like the entire list of everything that they'll provide you on a weather briefing if you call them. And I make students do this at least once. It's the old-fashioned way of checking the weather, but honestly, calling a weather briefer, it's like a free ground lesson on weather. So they'll ask you for your name and your tail number. They'll ask for the type of aircraft. They'll ask you for your route of flight, so like McClellan to Monterey. They'll ask you for the altitude you're going to fly at. They'll ask how long will you be en route. So let's say hour and a half. I'll be flying for about an hour and a half at 4,500 to Monterey. They'll ask you, they ask you a couple other things like, your takeoff time, estimated time of arrival, and are you VFR or IFR? Your answer will always be VFR until you get an instrument rating. And then they'll give you a general overview. They'll give you a synopsis. They'll tell you like, hey, that there's a low pressure system moving in from the coast. You got a cold front coming in at approximately this time. They'll tell you any adverse conditions, like if there's a lot of turbulence or icing reported. They'll even tell you if VFR flight is not recommended. You can't ask them that. You can't be like, okay, so would you say VFR flight's not recommended? Then they can't answer you. They have to just volunteer that information. So, okay, if this person's telling me VFR flight's not recommended, I'm probably not going to do it then. That's all they can say. They can't ground you. They can't tell you, yeah, you shouldn't fly or you can't fly. They're just going to tell you, yeah, VFR flight's not recommended. And you do with that information whatever you will. They'll tell you the winds at your altitude. It's called winds aloft. So if you're flying at 4,500 feet, they'll tell you, yeah, the winds aloft are from the west at 16 knots. So they give you a lot of good information. They will break down, like if there's a cold front coming in, they'll kind of, or there's a low pressure system, you can ask them, so if there's a low, hey, I'm a student pilot, and if